Alright, welcome. In this video, I'll be doing a short tutorial on how you can use ADS to design a L matching network. And we're going to make ADS do all the work for us. So this is a super cool tool, and I hope you enjoy. Okay, so after you've got a little circuit set up like this, where you have your S parameter simulation, your S port, and some sort of impedance going on at the end, some sort of load impedance. Let me set this to 100 plus J 50 ohms. Once you get this sort of circuit, go ahead and click Design Guide followed by Filter. You may be tempted to click on the impedance matching option. However, this is not what you might be imagining, as this will not allow you to set any given Q. Go ahead and click Smith chart. It'll pull up a window that looks like this. Here, you can set whatever frequency you'd like to match it to. Since we're doing 1 to 10, let's go ahead and choose a frequency of 5 gigahertz. You can also go ahead and define the load and source terminations. I'm going to click Enable Load and Source Termination. That's going to grab the elements that I already have down on my circuit. So here I'll have to fix this to say 100 plus J times 50 ohms. Click Apply. Oh, I'll have to set this to be a complex impedance, of course. Alright, go ahead and click Apply followed by OK. And we can now begin to start designing our little matching network using this Smith chart. So the first thing we'll need to do is actually place down a smart component. If you click on this little chocolate bar looking thing, it'll pull up the smart component. And we can place it down right away. Now, we should wire it up. And we can go back to the design guide and open the Smith chart. Here we'll want to update the smart component from the Smith chart utility. This will grab all the settings we previously set and put them in this thing that we've already designed down here. Alright, from here we want to make sure that we've locked our source and load impedances, because we want this to be matched at exactly our Z naught value. And so we'll use 1 for the normalized value. So there's a couple different things you can do. You can actually use this palette over here to place down your own components and make something rather complex. For this video, I'll just use the Auto 2 element match. You can choose the high or the low pass filter, and then it goes and designs it immediately for you. Super convenient. From here, what you'll want to do is just go ahead, close out of this window, and simulate it to make sure that everything works. Alright, so what we'll do is we'll hit the Simulate button, place down a Smith chart, select S11 and add it to our Smith chart. Now we can go ahead and click on the marker value, click New, we can place it down on the trace, and we can set it at exactly 5 gigahertz. Or we can alter the value here actually to make it exact. You can see that at exactly the frequency we told this thing to match it to, it's at exactly the center of the Smith chart. So this circuit's matched. Now, as I mentioned, there's the other, let me close out of this. There's the other design guide, which is the impedance matching. You can use this to make some pretty interesting circuits. However, I do prefer the Smith chart as it allows us to set a specific Q value. Thank you for watching.